Question number 19 is clearly a probability tree diagram question because you've got one right here. But let's have a read of it and see what it says. So Kirsty either travels by bus or walks when she visits the shops. The probability she catches the bus to the shops is 0.3, and the probability she catches the bus from the shops is 0.8. So what we have to recognise here is that to the shops and from the shops are independent events of each other. The second event is not dependent upon what happened in the first event. And what we have to know here as well is that these two probabilities, so the one that's missing here and this one that we have been given here on our tree, add up to 1. So very easy to fill in the missing number here as 0.7, because that would make 1 if we were to add these two numbers together. Now, if we read the writing again at the top, the probability she catches the bus from the shops is 0.8. And we can pop that 0.8 here, 0.8 along this branch, and we pop the 0.2 here along this branch. And again, bus is 0.8 and walk is 0.2. If we fill that in correctly, we get 2 marks, and that is it. So we've done part A, we've completed the tree diagram. And part B, we have to show the probability that Kirsty walks at least one way is 0.76. So we have to follow the strands along the probability tree. Now, when you follow the strands along a probability tree, you have to think about multiplying the numbers that you've got together and work out the probability that if we were to follow this strand, if she got the bus to the shops, multiplied by the chance she got the bus from the shops would give us the chance she got the bus both ways. We're not interested in that because we have to show the probability that Kirsty walks at least one way. So that way we're not bothered about. We don't want to know that way. And we could use that way. We can multiply these two numbers together, decimals together, and then we could minus that from 1. But I think the easier way to think about it is a little bit longer, but it's an easier way to think about it potentially, right? If we think about getting the bus and then walking, okay, so we write down this notation, the probability of getting the bus and walking. So that's walking at least one of the ways is equal to 0.3 multiplied by 0.2, which is going to be 0.06. Okay, you could use a calculator for that if you wanted to. Okay, you've got the way that we're following here is you walk and then you get the bus back. So that's the probability of walking and then getting the bus back is equal to, if we multiply 7 by 8, we get 56. So 0.56 will be our answer there. And if we then follow the strand for walking and then walking back as well, we're going to do the probability of walking and walking. WW, this is just a notation we use to represent this, is equal to 0.7 multiplied by 0.2, which is 0.14. Now, at least one way, we found the 3 different ways that you could be walking, right? Walking both ways, walking once there, walking once back. All we have to do is add these numbers together. So if you add those numbers together, you get 0.06, 0.56, and 0.14. Added together gives you what we're after. So we've got 6, carry the 1 underneath. We could use a calculator again to do this, but obviously we're having to show that we knew we needed to add these numbers together. So that's 6, that's 7, and then nothing to carry over, 0, 0, 0. And there we have, we've shown that that works out to be the number they wanted it to be.